Now just to give you an idea on how stupidly powerful this laser is, I have a couple other lasers here to compare it to. So this laser right here is 5 milliwatts. So a direct hit from anything stronger than this is going to cause eye damage faster than you can blink, or even just a reflection off of a shiny surface. Now this laser right here is 500 milliwatts, or half a watt. So that puts it in the highest laser danger rating there is. So that means that not only is it a fire hazard, but just looking at the spot on a surface can burn your eyeballs out without goggles. And then there's this laser, which eclipses that rating 200 times over. I mean seriously, there's no sane reason for something like this to even exist, and yet here I am, flaunting it on a YouTube video. Okay, so what can I even do with it? The same thing as any other gadget that isn't boring. Light stuff on fire. Check out how the raw output just torches my desk. I'm not even using a lens here. The power density is already way higher than my laser bazooka. As for the other burning tests, let's start with the easy stuff. I wonder how fast I can pop these balloons with the laser. That never gets old. Let's try it on a paper bag. Huh, well that's terrifying. Geez, that lit on fire like nothing. Yeah, this thing is a lot of fun. Can the raw output ignite wood? I'll take that as a yes. How about a ping pong ball? Alright, that's pretty cool. It turns out ping pong balls are surprisingly flammable due to their nitrocellulose content. Speaking of nitrocellulose, here's a little bit of flash paper. Since I'm already igniting a bunch of random stuff, I might as well put that chemistry degree of mine to use and whip up something exciting. Huh, I love lighting stuff on fire. This right here is one of my most requested laser experiments. Can I cook a steak? One way to find out. That smells so good. Listen to that baby sizzle. Huh, and you thought microwaves were bad at cooking food all the way through. Some people might ask, how hot is the beam itself? Well, the thing is, there isn't actually a temperature. Yeah, it's hot. Okay, well the beam doesn't exactly have a temperature, but it certainly can heat up objects very quickly. Now, how hot depends on a lot of factors, but this piece of wood here heats by hundreds of degrees in under a second. Let's tackle another popular viewer question. Can I send electricity down the laser beam? To test this, I have a voltage multiplier stack that produces very high voltage DC. When the leads are close, the field is strong enough to ionize the air and cause an arc to form. But when they're further apart, the field is weak enough that the only current that passes is from corona. Now when I shoot a laser between the gap, there's no arc as the beam is not conductive. Now if the laser were millions of times more powerful, it could rip apart the molecules in the air to make a conductive plasma, but unfortunately I can't do that with this laser. I can cheat a bit using fire though. By sticking some matches between the gap, I can ignite them with the laser to generate some thermal ions. What happens here is that these ions get accelerated by the field and then smash into other neutral molecules in the air, which generates more ions. This process cascades until you have a giant arc between the electrodes. Alright, so the raw output of the laser is certainly impressive, but I still think I can do better. I wonder how much more damage it could do if I use a lens to focus down the beam. A smaller spot means more damage. A shrink in the beam size in half will actually quadruple the power density on the target. I mean, anybody who's played with a magnifying glass on a sunny day can attest to this. But that being said, using a lens to focus down a laser ray does have its issues. Even from simple ray optics, you can see that a lens doesn't actually combine the beams, as it also images the gaps between them. Plus, you have effects like spherical aberration, and the fact that each individual beam is diverging, and anisotropically to make matters worse. But the thing is, using any sort of beam correction on an integrated array like this is incredibly difficult. As far as lens systems go, I found what's probably the best option for the laser in a prototype projector I had sitting around. It's a big AR-coated F-theta lens that's rated for high laser powers. I made a mount for it using PVC fittings, and then stuck it in front of the laser array. So how much more damage can it do? Using a piece of wood as a target shows that the beam shrinks to a fifth of the original size, which means a 25-fold increase in power density. It's crazy how instantly wood ignites in the beam. This makes it really great at engraving wood. I've never had a handheld laser that scorched wood so easily. There's nothing like a nice, refreshing bottle of soda after a long day of building death rays. But it looks like I forgot to bring a bottle opener. What am I supposed to do now? Oh yeah, I almost forgot. I can just use the most powerful handheld laser in the world. Well, that's certainly frightening. Yeah, that's molten glass you're looking at. That was probably the most metal thing I've ever done on this channel. I wonder if I can use the laser to burn DVDs. Huh, do you get it? How about some coarse steel wool? Ooh, pretty orange sparks. Okay, this one's total overkill, but let's cut some electrical tape. And that was pretty satisfying. Can the laser strip the paint off of this steel lid? One way to find out. Huh, it works, but not very great. Actually, it seems to be damaging the metal itself. Okay, that's pretty ridiculous. I wonder if the beam can punch all the way through. Wow, that's crazy! I did not expect to see the day where I could shoot through metal with a handheld laser. Like, that's just unbelievable. It wasn't even that long ago that a blue laser of this strength would require the setup the size of a building to operate.
Sei sotto un cielo sbagliato.